It's like staring at the most beautiful prison ever built. Endless, glowing, and utterly unreachable. No matter how far we dream of going, the universe keeps reminding us we were never meant to leave. Imagine, just for a second, standing on a beach at night. Not just any beach, but the shore of an entire galaxy. Above you, a breathtaking river of stars cuts across the velvet blackness. The majestic disk of our Milky Way, home to hundreds of billions of suns, swirling around a supermassive black hole. It's stunning, awe-inspiring, and suddenly, profoundly claustrophobic. Because the terrifying, mind-bending truth is this: we are trapped here. Physically imprisoned, right now, on our little cosmic island. The distances between stars are so vast, the speeds we can achieve so pitifully slow compared to the scale of the universe, that even reaching our nearest neighbor star, Proxima Centauri, feels like an impossible generational odyssey. Forget zipping across the galaxy like in the movies. With current technology, crossing the Milky Way would take hundreds of millions of years. Escaping its gravitational grasp entirely? Utterly, hopelessly out of reach. It feels like a cosmic cage. But what if there was a secret passage? A cosmic shortcut, hidden within the very fabric of reality itself? What if the key to unlocking the galaxy, perhaps even the universe, lies within one of the most tantalizing, controversial, and mind-bending concepts in physics: the wormhole? Buckle up, because we're diving deep into the warped heart of space-time to uncover the shocking truth about wormholes and our desperate hope to escape the Milky Way. First, let's confront the sheer, overwhelming scale of our prison. The Milky Way is colossal. Picture it: a vast, spinning disk roughly 100,000 light-years across. 1 light-year is the distance light travels in a year, nearly 6 trillion miles. That means light itself, the fastest thing in the universe, takes 100,000 years just to cross from one side of our galaxy to the other. Our fastest spacecraft, tiny Voyager 1, hurtling outwards at about 38,000 miles per hour, would take over 70,000 years just to reach the next star over, Proxima Centauri, a mere 4.2 light-years away. To cross the galaxy? Forget it. We're talking timescales longer than the existence of the human species. It's like trying to cross the Pacific Ocean in a bathtub powered by a rubber band. And escaping the galaxy entirely? That's an even bigger leap. The Milky Way's gravitational pull extends far beyond its visible stars, deep into the vast, dark halo of mysterious dark matter. Breaking free means achieving speeds far beyond anything our rockets can muster, venturing into an incomprehensible void between galaxies. The sheer distances and timescales involved make interstellar travel, let alone intergalactic escape, seem like pure fantasy. We are, for all intents and purposes, marooned. This feeling of cosmic confinement is why the idea of wormholes hits so hard. It offers a glimmer of hope, a potential cheat code written into the universe's operating system. So what exactly is a wormhole? Imagine space-time, the four-dimensional fabric combining the 3 dimensions of space with time, as a vast, flat sheet of paper. If you want to get from point A on one side of the paper to point B on the other, the longest way is straight across the surface. But what if you could fold the paper, bringing points A and B directly together? Punch a hole through the fold, connect them with a tunnel, and boom. You've created a shortcut, a wormhole, often called an Einstein-Rosen bridge. In theory, it's a tunnel with 2 mouths, connecting 2 distant points in space-time. You enter one mouth, traverse the throat, and emerge almost instantly from the other mouth, potentially light-years, millions of light-years, or even billions of light-years away. Think of it like a cosmic subway system, bypassing the vast, empty stretches of normal space. The concept arises directly from Einstein's theory of general relativity, which describes gravity not as a force, but as the warping of space-time by mass and energy. Massive objects like stars and black holes create deep wells in this fabric. Wormholes are solutions to Einstein's incredibly complex equations that suggest space-time can be so profoundly warped that it folds back on itself, creating a bridge. They aren't magic. They are potential geometry, extreme warps predicted by our best description of gravity. The idea isn't new. Physicists Ludwig Flamm, Albert Einstein, and Nathan Rosen explored them theoretically back in the 1930s. but understanding their potential as shortcuts? That came later, capturing the imagination of scientists and science fiction writers alike. Now, before you start packing your bags for Andromeda, we have to confront the brutal, universe-shattering reality about wormholes. The truth is far stranger and more challenging than any sci-fi movie depicts. The first massive problem? We have never seen one. Not a single, confirmed observational hint. They remain entirely theoretical constructs, mathematical phantoms lurking in the equations of general relativity. The second, even bigger problem? Natural wormholes, if they exist at all, are almost certainly useless for travel. Here's why. They are predicted to be incredibly unstable. Imagine that tunnel made of space-time fabric. The moment it forms, the equations suggest it would snap shut faster than the blink of an eye, pinching off instantly, collapsing before even a single photon of light could traverse it. It would be like trying to walk through a tunnel made of soap bubbles that pops the instant you touch it. Think nanoseconds, or even shorter timescales. Totally useless. But wait, it gets worse. The exotic matter problem. To prop open a wormhole, to prevent its instantaneous collapse and make it traversable, physicists like Kip Thorne realized you'd need something truly bizarre. Exotic matter. This isn't just weird stuff. It's matter that possesses negative energy density. Think anti-gravity stuff. Matter that warps space-time in the opposite way normal matter, which has positive energy density and creates gravity, does. You'd need this exotic matter to line the throat of the wormhole, acting like scaffolding to hold it open against the crushing force of gravity trying to slam it shut. And here's the kicker. We have absolutely no proof that exotic matter exists in the necessary quantities, or even at all, in our universe. It's purely hypothetical, appearing in some speculative quantum field theories, but never observed. Without it, the wormhole tunnel collapses faster than you can say black hole. Let's push the science fiction button for a moment, though. Suppose, somehow, we found a stable wormhole or figured out how to create and stabilize one with exotic matter. What then? Could we really use it to escape the Milky Way? The potential is staggering. A wormhole mouth placed near Earth, linked to another mouth flung far beyond the Milky Way's gravitational influence, perhaps near another galaxy entirely, would be the ultimate escape hatch. Step through, and you're free, instantly bypassing hundreds of thousands of light years of interstellar and intergalactic void. It wouldn't just be about escape. It would be about instantaneous travel across cosmic distances, opening the entire observable universe to exploration. Imagine colonies not just on Mars, but in entirely different galaxies. But hold on to your spacesuit, because the challenges become almost comically immense, venturing deep into the realm of hypothetical physics and engineering on a godlike scale. Finding one. How would we even detect a naturally occurring wormhole, assuming they exist in a stable form? Maybe through gravitational lensing effects, weird distortions of light from objects behind it, or unique radiation signatures. We don't really know what to look for. Creating one. This is pure mega-engineering fantasy on an unimaginable scale. We're talking about manipulating space-time itself, concentrating truly astronomical amounts of energy, think energies rivaling supernovae, or even more, into a microscopic point to twist the fabric of reality into a stable tunnel. We have zero clue how to even begin stabilizing it. As discussed, this requires exotic matter. We need to discover it, understand its properties, and then harvest or produce it in vast quantities. Negative energy densities are incredibly weird physics, potentially violating fundamental energy conditions that hold our universe together. Controlling the exit. Where does the other end open? How do you ensure it doesn't dump you into the heart of a star, a black hole, or the crushing vacuum of intergalactic space billions of light years from anything? Navigating or aiming a wormhole adds another layer of near-impossible complexity. The time factor. Wormholes aren't just space tunnels, they're space-time tunnels. General relativity shows they could theoretically be time machines as well, leading to paradoxes, like killing your own grandfather before you're born, that make physicists deeply uncomfortable. The laws of quantum mechanics might prevent such paradoxes, but it's a major headache. So where does that leave us? Stranded forever in the Milky Way? Well, maybe not entirely hopeless. While traversable wormholes remain firmly in the realm of deep theory and extreme speculation, The pursuit itself is pushing the boundaries of human knowledge in fascinating ways. Scientists are actively investigating the extreme warping of space-time around black holes using incredible instruments like LIGO and Virgo, which detect gravitational waves, ripples in space-time from colossal collisions, and the Event Horizon Telescope, which famously imaged a black hole shadow. Understanding these environments, where gravity is pushed to its absolute limits, is crucial for testing the predictions of general relativity and exploring the possibility of space-time structures like wormholes. Furthermore, the quest for a unified theory of quantum gravity, a single framework merging Einstein's gravity with the bizarre rules of the quantum world, which governs the very small, is vital. Wormholes sit right at this messy intersection. Some theories, like string theory, suggest wormholes might be connected to fundamental particles or exist as quantum foam, a seething sea of virtual particles and microscopic space-time fluctuations at the tiniest scales. Could we somehow manipulate this quantum foam, stabilize a microscopic wormhole, and inflate it? It sounds like pure fantasy, but exploring these ideas forces us to confront the deepest questions about the nature of reality, space, and time. The search for exotic matter, even if unsuccessful, drives research into quantum field theory and the vacuum energy of space itself. So, while we're not building stargates anytime soon, the investigation into wormholes isn't pointless. It's fundamental physics in its most daring and exploratory form. It forces us to ask, what are the true limits of space-time? What is possible when we push the laws of physics to the absolute edge? Here's the raw, unfiltered truth about escaping our galactic home. With our current understanding and technology, escaping the Milky Way via any means, including wormholes, is utterly impossible. Wormholes, as traversable shortcuts, remain a beautiful, tantalizing mathematical possibility, not an engineering blueprint. They are ghosts in the equations, plagued by instability and the need for physics-defying materials we don't possess and may never find. The challenges involved in finding, creating, stabilizing, and controlling one are so immense they border on the metaphysical. We are, for the foreseeable future, and likely for millennia to come, citizens of the Milky Way. But does that make the dream worthless? Absolutely not. The human spirit is defined by looking beyond the horizon, by asking what if, and daring to imagine the impossible. The concept of wormholes, however remote, embodies that insatiable curiosity. It drives scientific exploration forward, leading to real discoveries about black holes, gravity, and the quantum vacuum. It forces us to confront the fundamental structure of the universe we inhabit. And who knows, maybe, buried deep within the yet-to-be-discovered laws of quantum gravity, lies a mechanism, a loophole, a way to gently coax space-time into holding a tunnel open without needing magic matter. Maybe future civilizations, harnessing energies and technologies we can barely dream of, will crack the code. The universe is 13.8 billion years old. We've been doing serious science for a few centuries. Our story is just beginning. So, while wormholes may not be our ticket out today, they represent the wildest, most exhilarating frontier of physics, a symbol that the universe might still hold secrets that defy our current comprehension. They remind us that the cosmos is far stranger and more wonderful than we can imagine, and that the drive to explore, to break free, to reach beyond our cosmic shores, is written into our very DNA. The journey to understand them, and perhaps one day to find a way, continues. The dream of escape, fueled by the ghostly tunnels in space-time, lives on. Thanks for watching. Don't forget to hit that subscribe button for more documentaries like this. Stay curious, stay informed, and we'll see you in the next one.